Hello, just another example or a couple more examples for example 1, finding quadrants of the angle could be and the angle between 0 and 360 when you're given a ratio like this or a decimal like that, which is really just a ratio. So the first thing you would do is draw a diagram. So I'll draw a diagram here. It doesn't need to be fantastic, just a sketch. And I'm not sure which quadrant it's going to be in. So I look at the ratio. The ratio is negative, and if you think of your cast or all sandwiches taste crummy, sign is positive in the first quadrant and in the second quadrant, so it's going to be negative in the third quadrant and the fourth quadrant. So when I go to my diagram, I'm going to be looking down here or down there. Okay, right angles with the x-axis. Your reference angle will be close to the origin, so there and there. And then it's just a matter of putting this ratio into the triangle. So sine is opposite over hypotenuse, so the hypotenuse is going to be 2 for both of these. The opposite will be root 2, or negative root 2. So negative root 2, negative root 2. If you think about your special triangles, I'm pretty sure this would be root 2. This one would also be root 2, but because x is negative over here, it's going to be negative root 2. So negative root 2. Now you think of your special triangles. This angle has to be 45 degrees. This angle has to be 45 degrees. So then I've got two answers. One in quadrant 3, one in quadrant 4. And my theta is going to be equal to, in quadrant 3, I'm going to start at here at my initial arm, go all the way around to there. So it would be 180 degrees, sorry, 180 degrees there, plus the 45, so 180 degrees plus 45 degrees, which would give us 225 degrees. For quadrant 4 is a little bit different, so you have to go all the way around to there. I'm not going to go back to the y-axis, you always go to the x-axis. So this would be 360, and I'm going to subtract the 45, so work backwards from the 45. So my theta here would be 360 degrees minus 45 degrees, which is 315 degrees. So two answers, one in quadrant 3, one in quadrant 4, 225 degrees or 315 degrees. For the next one, I've got cos being positive 0.129. So I'm going to draw a diagram again. Start off. Little grid, just a sketch. Doesn't need to be exact. So I know it's positive, so I look at my my cast rule or quadrant where the angles and quadrants are related. Cos is positive in the first quadrant and the fourth quadrant, and that's what we have, a positive one. So we'll be looking in quadrant 1 and quadrant 4. Right angles with the x-axis. Now this is a little different. It's not a special triangle one, so what I have to do in order to figure out what the reference angle is I use my calculator. And since I'm solving for the angle, I'm going to press second function cos, or it might be shift cos on yours, and I'm going to put in that decimal, 0.1219, hit equals. That's the reference angle. So the calculator is telling me my reference angle is 83 degrees down here, which would mean this is 83 degrees. So my two answers will be in quadrant 1, which is 83 degrees. That's kind of nice. I don't have to do any thinking. In quadrant 4, my answer is going to be similar to the last one. I start here, go all the way around. So I'm going back to the x-axis, which would be 360 degrees. So I'd have to go 360 degrees minus 83, which I believe works out to 277. I want to double check that, but I think, sorry, I can't see that, but I think works out to 277 degrees. So there's my two answers, 83 degrees in quadrant 1 and 277 degrees in quadrant 2. Hopefully that's helpful, and you can learn how to do it.